So as I was saying in the presentation, you should have a plan before you go out sampling. The more time you spend on the front end, identifying which outfalls you want to get to in a given day, identifying what you need for sampling, whether it's test strips, meters, extra field bottles, because inevitably you are going to go out into the field, you are going to come across something that's going to prevent you from doing something you thought you were going to be able to do, and you need to be able to switch gears in the field almost immediately so that you're not wasting that precious time, because it does take a lot of time and effort leading up to it, and then getting in the field, you want to maximize the time you have in the field. So for field meters, has anybody used, a couple people have used field meters before. For whatever reason, like all scientific equipment, the longer you leave these things on, the happier they are. I don't know why that is, but that is definitely the case. So you should definitely turn your meter on 20, 30 minutes before you plan on actually using it. It's also helpful if you, for this particular meter, you should have the manual with you. I've got the manual in the binder there if anybody wants to take a look. But it does recommend that you put this in a calibration standard and let it acclimate to the temperature of your calibration standards before you calibrate the machine. This particular unit analyzes for conductivity, salinity, temperature, and pH. pH is something that's not required as part of this permit, but the meter does it, so you might as well take it at the same time. So as I was saying, the pH probe is down here. Temperature sensor on this unit is this little black nub right here. Those both have to be submerged for the pH meter to calibrate. pH is dependent on temperature. If you do not have the temperature probe submerged in your calibrating solution, you have a whole day of wasted data on your hands, because you'll inevitably find that out later, like, oh, I didn't have enough solution to go over the temperature probe. On this unit, conductivity and salinity, you can see the two holes sort of at the top of the meter, and then this other hole, the water is supposed to flow through, and the sensor is actually internal in here. So when you dip this in your sample bottle, all those holes need to be submerged, and you also want to agitate the water a little bit to get that water flowing through the cell to get a consistent reading of what the conductivity or salinity are in your water body or sample of interest. This is deionized water. So when you're talking to laboratories about doing E. coli sampling, I personally would be like, hey, throw me some DI water. Now, another way you can deal with the DI water, you can potentially use distilled water, but I would send the distilled water you're using to a laboratory to verify that it is free of whatever you are testing for. In my experience, ammonia, it'll come back potentially with a low level of ammonia using just distilled water from CVS or something like that. So you're better off using the DI from the laboratory. For this unit, calibration is fairly simple. You just press these two buttons at the same time. So on this unit, it tells you it's asking for a standard of 7. It's telling you it's in calibration mode. Put it in standard 7. When it stabilizes, this particular unit has an indicator. The decimal point stops blinking. Hit enter, move to your next standard. It'll automatically sense which direction you're going. Your standards for pH typically run 4, 7, and 10. This particular unit can also use 4.01, 6.86, and 9.18 if you want to get super technical. And then you do the same thing, hit mode, change the mode of the thing to conductivity, and then calibrate for conductivity. This particular unit, when you read the user's manual, when you rent the unit, it comes calibrated. So you can just check the calibration with the standard that they supply you. If that's reading normal, then you go out and use it. You also have the standard there to calibrate if you need to calibrate as well. Bring the user's manual with you in the field. Some people forget to do this. I cannot tell you how many times I've received an error message from the unit in the field, and it'll say like error 7. In the user's manual, it'll tell you, and sometimes it's as simple as unplug it and all that. Some of them are kind of rudimentary, but it does save some hassle when you can fix things in the field. So you have to have sample bottles available to you for everything you need to analyze for without contaminating other samples. So you may choose to have a sample bottle for E. coli that's going to the lab, a sample bottle for ammonia, a specific sample bottle for surfactants, and deal with it that way. Or you could take, a larger sample bottle and then divide it up in your analytic space, whether that's either a tailgate of a truck or back at a facility, and do it that way. It's up to you. I personally, like I said, I typically like to bring all my samples to one centralized location, so I use liter bottles, take one sample, bring it back, divide it up there.
Keep them all on ice and just bring them back.
Yep, keep them all on ice and bring them back. And in my experience, the more sample you have, the better. Because you're always going to run an analysis and be like, that didn't go right. That's not right. I need to do that again. And you can't do it again if you don't have sample.
I just got a little confused as I was reading the part about when the methods were being dictated by EPA, when they wanted specific methods used.
Specific methods need to be used for E. coli and the specific pollutants of concern, which is typically E. coli for a lot of the watersheds that have TMDLs for bacteria. Phosphorus, that's another one that needs to be an EPA specific method, I believe. We can check the permit. But they call out all those, and they specifically say which ones you can use test kits for. I would default to that. Like if they say you can use test kits for ammonia, chlorine, surfactants, everything else needs to be EPA certified methodology. Of which, I don't know, the person who asked about Cow Alert. Cow Alert is an EPA approved methodology. Cow Alert and Entro Alert are the two bacteria tests. They did not used to be EPA certified, but it is in the Federal Register. So for these test strips, the instructions are on the side of the bottle, and also the comparative portion of the test is also on the side of the bottle. So what's going to happen is we're going to dip these in, choose either solution, it doesn't matter. You're going to swish it around for 30 seconds. All right, you can remove the test strip. Now it needs to sit for 30 seconds, and you're going to read it so the pads need to be face down. And then you're going to compare it to this. Now these test strips will work for ammonia. As I mentioned in the presentation, chlorine is another parameter that you will have to test for.
He's off the chart here.
Yeah. Yeah, mine's blue, not green. So.
Yeah, like
Yeah.
off.
So to give you an idea of the concentration, so the bottle on the right, which is what you have, which is off the chart, correct? So that was basically 2 milliliters of just household ammonia in that entire bottle, produced that result, which is, again, off the charts when it comes for terms for the permit.